start with displacement reactions. So before going to displacement reactions, I'm gonna tell that we have discussed about combination reactions, decomposition reactions in our previous videos. So please go through those videos so that you can understand the other following videos easily. So it's better to start with this video after going through the previous videos where I have taught. Now we are going to start with the displacement reactions. Here also we have an activity. Now take 3 iron nails and clean them by rubbing with sandpaper. Okay, take 3 iron nails. Use a sandpaper to rub. We have used sandpaper in a first experiment also, like for rubbing the magnesium ribbon, right? So remember that. Take 2 test tubes marked A and B. In each test tube take about 10 ml of copper sulfate solution. What we need to take? We need to take copper sulfate solutions in both the test tubes. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in the test tube B for about 20 minutes. Okay, this is the test tube B, and for 20 minutes immerse those nails into the copper sulfate solution. Okay, next, after 20 minutes take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of the copper sulfate solution in the test tubes A and B, figure 1.8b. So after taking out the iron nails from the test tube B, you could find that the intensity of the blue color had decreased than before. Also compare the color of the iron nails as well. The iron nail which is taken out from the copper sulfate solution and the iron nail which is a before, which is a clean iron nail. We have taken 3 iron nails, that one. Okay. So what is this activity? I'll tell you once again. So now take some copper sulfate solution which is blue in color initially. Now place 2 iron nails into that, immerse 2 iron nails into it for 20 minutes. After 20 minutes take out these iron nails, where you could find that the iron nails kept in the test tube B would turn into brownish color, whereas the iron nails which are fresh, where they are not kept in any of the solution, are at their initial position. If you look at the test tube, as we have placed these iron nails in the test tube B, you can observe that the color of the test tube, the copper sulfate solution present in the test tube B, decreased while compared to the test tube A, where you have kept nothing in it. Okay, so this figure says that iron nails and copper sulfate solution compared before and after the experiment. Now in everyone's mind there would be this doubt that why does iron nail become brownish in color and the blue color of the copper sulfate fades away. So let's see the following reaction which had taken place in the chemical reaction, that is Fe plus CuSO4 gives rise to FeSO4 plus Cu. Okay, in this reaction iron has displaced or removed another element, copper, from copper sulfate solution. So what we have iron, we have copper sulfate. So in copper sulfate, the copper in the copper sulfate is displaced by the iron which is present in its free form. Okay, and this reaction is known as a displacement reaction. The name itself says a displacement, that is you are taking something from something, that is from the copper sulfate solution copper is taken out by the iron, and this results in a displacement reaction. Other examples are Zn plus USO4. If you observe this carefully, if you observe, the copper was replaced by Fe, that is FeSO4 plus Cu. Here also Zn plus USO4 gives rise to ZnSO4 plus Cu, that is Cu was replaced by zinc. Here also Cu was replaced by Pb, that is lead, and it forms PbCl2. This is what actually the phenomena behind the displacement reactions, that is one element is displaced from its compound by another metal, norm or whatever, by another one reactive element. Simply you could say that the more reactive element is replacing or is displacing the less reactive element in its compound state. Zinc and lead are more reactive elements than copper. They displace the copper from its compound. So this is the displacement reaction. Now let's know about the double displacement reaction as well. Take about 3 ml of sodium sulfate solution. You take sodium sulfate solution. In another test tube, take 3 ml of barium chloride solution. Okay, now mix the two solutions, and what you can see at last, you will observe that a white substance which is insoluble in water is formed. The insoluble part which is formed in water after the reaction is called precipitate, and these type of reactions are called precipitation reactions. Here you could find that the ions in both the compounds have got exchanged, got displaced, that is more reacted one displaced the less reactive one and formed a new compound. Like in case of the single displacement reaction, here also the displacement took place but between the ions. So you will observe that a white substance which is insoluble in water is formed, and this insoluble substance is known as precipitate. That produces a precipitate is called a precipitation reaction. The reaction between sodium sulfate Na2SO4 plus BaCl2 gives rise to BaSO4 plus NaCl. Now, what causes this? The white precipitate of PaSO4 is formed by the reaction of SO4 2 minus and Ba plus 2. The other product formed is the sodium chloride, which remains in the solution, and such reactions in which there is an exchange of ions between the reactants are called the double displacement reactions. I have told previously that there is an exchange of ions, then you call it as a double displacement reaction.